Alright, 6-3 day 2, eliminating using addition and subtraction. So today we're going to do word problems, real word applications. This is, remember, word problems is how you'll see systems a lot on your EOC. So let's practice our word problems. Now, we are going to write and solve systems using addition. Now remember, with addition, what you're searching for are opposite signed coefficients. Okay, opposite signed coefficients. So the ones on the front, they're just straight up math in words. All right, so let's convert these words into a systems of equation. So with these, one sentence equals one equation. The second sentence will equal the second equation. Okay, and also in the notes, it gives you that's XY. On the assignment, it will not give you the specific letters XY for the majority of them. So this first one, 7 times a number. That's where the assignment's going to stop. But in the notes, it gives you X. So 7 times a number. 7 times X. Okay. Minus, there's a math word. Minus. 4 times another number. Okay, that's how you will see it in your assignment. But this one, in the notes, it gives you Y. So 4 times another number. 4 times another number is equals 13. We did one sentence, we have one equation. Okay, second sentence, second equation. -7 times a number. Okay, -7 times a number. That's what you would see in the assignment. In the notes, it gives you that it's X. So -7 times a number, so -7X. Plus 7 times another number. Again, that's what you will see in your assignment. This one gives you Y. So 7 times another number is equals 14. Find the two numbers. Okay. Well, we have opposite signed coefficients, so we're going to add. We have successfully eliminated that term in both equations. So now we have -4y plus 7y, that's 3y. And 13 plus 14 is 27. Last step, y equals 9. We have found y. Now let's find x. We could use either equation. I'm going to use the top one. So 7x minus 4. Y is 9 equals 13. So 7x minus 36 equals 13. We will add 36 to both sides. Last step. X equals 7. We found our x, we found our y. Remember, you write it in an ordered pair, x, y. So 7, 9. And this is the work I want to see. Okay? So, let's try that again. Okay? Let's try that again. So again, remember, one sentence, one equation, second sentence, second equation. So 2 times a number, so 2 times a number, minus 6 times another number is -6. Second sentence, -2 times a number plus 5 times another number is 18. All right, we have got 2x and -2x. These are opposite sides opposite signed coefficients. So we are going to add, so we can eliminate those terms from both equations. And negative 6y plus 5y is negative 1y. Negative 6 plus 18 is 12. You cannot have a negative variable. It always has to be positive. So y equals negative 12. We found our y. Now let's find our x. We can use either equation, does not matter. I am going to use the bottom one. So minus 2x plus 5. The value of y is minus 12 equals 18. So minus 2x minus 60 equals 18. We'll add 60 on both sides. Minus 2x equals 78. Last step. X equals negative 39. We have our x, we have our y. We write them as an ordered pair. All right, and again, exact same essential question as yesterday. How do you know when to solve a systems of equation using addition versus using subtraction? So exact same essential question. Let's go on the back. Now I will let you know that the first problem on the back has a typo. It was pointed out in third period, and I went on planning and I looked at the teacher book and realized that the question is asking for the wrong thing for what we're solving for. So we're going to fix that as we read through it. Okay, so computers. May and Kara build computers for parts and sell them to make a profit. So we have two characters building computers, and they build them, okay, and they make a profit. So they do two things with those computers. So it says May can build a computer in 8 cents of an hour. So we got May can build in 8 cents of an hour. And Kara can build in 1 hour. All right. And what else do we have? We've got together. So together, they worked 15 hours. All right. And built 17 computers 1 week. Okay, cool. Here is where we have the discrepancy in what the question is. So let's fix this. Okay, let's fix this. So what we're going to find out is not how many hours, okay, each girl worked. We aren't finding that out. Here's what we are finding out. We're going to find out how many computers that each girl made. Because that is literally the question that gets answered in the book where I got this from. And so that is the question we are going to answer. How many computers did each girl make? Yeah, that's a little better grammar, but that's okay. Good thing I am not your English teacher. I'm your math teacher. But we are going to talk about subjects and verbs. Okay? So we have subjects. Okay? What are we talking about all the way through? What's the action happening to? Well, it's happening to the computers. Okay? But we have people doing the things to the computers. So we have our subjects. Okay? We have our subjects. We're going to label our subjects. We have X and we have Y. Well, we're talking about computers. And whose computers? We're going to talk about May's computers with X. okay? Because we want to differentiate with Y's computers, which are Kara's computers. Yep, if I could spell computers properly. Okay, that's our subject. So that is who this whole little story is about. It's about computers. That's what the action is happening to. And we have whose computers they are. They are May's and Kara's. So that differentiates our X versus our Y computers. All right. So when you have subjects or nouns, you also have verbs or actions. All right. So what kind of actions are we having? And these are going to be our equations. So we have two actions happening. We are building, and it's taking hours to build, okay? So we're going to have one equation talking about the hours to build, okay? And then we also sell, okay? So they build and they sell. Well, you can't sell a computer before it's built, all right? So these are going to be built computers able to sell. Because they have to be built in order to sell them. All right, let's see what we were given for hours. Let's see, hours. Well, we know the total hours worked is 15 hours. All right, so whatever it is equal to 15 hours. And then we look to see if we are given any other data or information about hours to build, especially with our subjects. So we do know that May, for May's computer, for May to build a computer, it takes 8/10 of an hour. So 8/10 X. And then we also know about Kara building hours. All right, so Y, she takes 1 hour. So 1Y. And together, so math for together is addition. So we are adding. Okay, so now we have our equation for hours to build based on our data. Hours, 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 hours. They all the numbers relate to the exact same thing, which happens to be hours, okay? All your terms have to be related to the exact same thing, which in this case is hours to build. Let's see what information we have for the built computers that we're going to be able to sell. Well, up in here, it says, and built 17 computers 1 week. So all we have is a total number that we built. We don't have any more data about these 17 computers, but we do know that May built some, and Kara built some, and together, both of them built 17 computers 1 week, okay? So again, built, built, built. They all belong together, okay? So we've built our system, pun intended. So now we are going to look, okay. So we are using subtraction, which means we want same signed coefficient. Same signed, same coefficient, +1, +1. So we're going to use subtraction. All right, so 8/10 x minus 1x is negative 2/10 x. 1x minus 1x, we've canceled a whole term. We've eliminated a whole term, which was our goal. And that equals, well, 15 minus 17 is negative 2. Now we're going to divide both sides by negative 0.2, and I'm going to highly recommend a calculator because x equals 10. We found x equals 10. Now we have to find y. We could totally use that top equation. I'm not gonna, but we could. I'm going to use my much easier equation here because 10 plus y equals 17. What's y? 7. Okay. Now, did I have to show work? Yes, I did. Could I have used substitution instead of elimination? Yes, I could have. When I was prepping this on Saturday evening and binge watching Virgin River simultaneously, I wasn't thinking when I was prepping this assignment, and I did this equation via substitution. And then I was like, wait, we are supposed to be using elimination. But you can see it took significantly more math to find the exact same answer. So, can you still get the same answer out of the way? Yes. Would it take a little longer? Yes. Would you know that ahead of time? No. Okay. But just know, the math's the same. It still works out. All right. Now let's see what 10 and 7 talk about. Okay, so X. How many computers did each girl make? Okay, that grammar is bothering me. There we go. Easy fix. So X is May. May made, built 10 computers. Kara made or built 7 computers. Now, here's the thing I want to warn you about. I always tell you to label your variables. Write them out. Take that time, because here's what's going to happen on the EOC. You're going to get the right answer. And when you look at your answer options, you're going to see the right answers with May and Kara, and with Kara and May. And if you don't know who is X and who is Y, you could do all the math properly and still get it wrong, because you didn't take the time to label who was X and who was Y. So I can guarantee you the state is going to try to trick you in that way. How do I know? Because they try to trick us teachers when we do our teacher certification in the exact same way. So I do this because I want you to do it, and I want you to get in the habit of it, so the state can't trick you, because they will try. Okay? All right. Let's check out this next one. Next one's about sleep. Everyone's favorite subject. All right. So Gallup poll asked Americans how many hours of sleep they usually get. Okay. So the difference, hey, what kind of math is the difference? The difference is subtraction. Okay. The difference between the percent of adults who slept more than the recommended amount of time, and the percent who slept less than the recommended amount of time is 3%. And that's a whole sentence right there. And let's see. Now, in total, these groups make up 25% of the population. What percent of the population sleeps more than the recommended amount of hours, and what percentage sleeps less? Use given information to write and solve the systems. All right, we aren't given a whole lot of information here, okay? But who are our subjects? We've got X and Y. Who came first, all right? We're talking about adults, and they slept more than. Okay, so the adults that slept more than the recommended amount of time, and the adults who slept less than. Excuse me. All right, so we have two types of adults. All right, so we have a math sentence. So the difference, so we know there's subtraction. So the difference between the percent of adults who slept more than, well, that's X, and the percent of the people who slept less than, well, that's Y, is 3%. Okay? That's one math sentence. Now the total of these groups make up 25%. So if you're finding a total of two groups, you're combining two groups together, well, you're adding. So we're adding. And who are we adding? Well, we're adding the more than and the less than people together. So we created an entire system from not a whole lot of information. Okay? Now, this one, we could do addition or we could do subtraction because both fit. But we're on the back side and it tells me to use subtraction. So we're going to use subtraction because we're on the back side and that's what we're supposed to be practicing. Now, if we're using subtraction, we are looking for the same signed coefficient. So the same signed coefficient, which would be X and X. They are the same sign, okay? So we use negative. Remember, when these are the ones that will get you, all right, which is why I circled them. Because if you were to do addition, we would be eliminating the Y, because they are opposite signed coefficients. But because we're doing subtraction, we are eliminating the X. Okay? Opposite sign, same sign. So we're going to subtract. We're going to eliminate our X. All right, so minus Y, minus another Y, minus two Y's all together. 3 minus 25 is minus 22. Divide by negative 2. Y equals 11. Now, would it make sense if I got a negative number here? Would it make sense to have a negative amount of people? It would not. A negative number would mean we were counting people who were dead. We don't have negative people, okay? So when we are dealing with these, if you get a negative number, you get a decimal, and it doesn't match or fit the situation, chances are your math's wrong somewhere, okay? We aren't pulling dead people, just saying. All right, so we can literally use either one of these, and in class, I literally put down both. So Y minus 11 equals 3, and X minus 11 equals 3, and X, sorry, I'm getting tired, plus 11 equals 25. The math still maths the same, all right? And mentally, I had y'all do this and tell me what X was. And no one told me exactly which equation they used, but they were all able to tell me that X is 14. 14 minus 11 is 3, and 14 plus 11 is 25. Okay, so we were able to get to X equals 14. Now, what does that mean? What does 14 and 11 mean? That's our ultimate goal, is to be able to label these numbers properly. That is why I define my variables very first thing always. So with X, okay, we want to know what percent, okay, and X is more than, so 14% of these adults fall under the more than category. They get more than the recommended amount of sleep. And my less than percentage, 11%, are my less than adults. And I can assure you, this would be one of those where, again, you would have multiple reasons with the same numbers, where the numbers would be flipped. or instead of more than and less than, they would have different descriptors in there, just literally to try to throw you off, okay? So take the time to define your variables so that the state can't trick you. All right. Your assignments for this, let me see, this was 6-3, day 2. It's in McGraw-Hill. It's 4 problems. Show your work. All right. Make sure you show that work on paper and turn it in for credit. Good luck.